Aldehydes and ketones. Both of these compounds contain the carbonyl functional group, a C double bonded O in their carbon chain. So to figure out if you've got an aldehyde or a ketone, you've got to look at the placement of the carbonyl group because it's different for aldehydes and ketones. So aldehydes, the carbonyl group is always on an end carbon, so a terminal carbon. And that carbon also has a hydrogen attached. So this is called a formal group for aldehydes. When naming aldehydes, identify the longest carbon chain containing the C double bond OH group, and that becomes your root. You drop the E off of the alkane and you add Al. There's no numbers needed for aldehydes because that will always be carbon number 1. You're going to number from that end because it has preference over any other side group. Identify any prefixes based on side groups and their position relative to that formal group, that C double bond OH. So this is the simplest aldehyde. So there's one carbon, so it's meth for methane. But we take the E off and add Al, so methanal. So for this structure, here's our formal group. That's carbon 1, 2, 3, 4, 5. So this compound would be called pentanal. Pent-ane, take off the E, add Al, pentanal. Okay, so I haven't drawn all the hydrogens in on this one just to make it clearer for you. So here, the longest continuous carbon chain containing the functional group is here. There's 4 carbons. That makes this carbon a side group. So there's 4 carbons, so this would be butane. So that's butanal, and that would be carbon number 1, so the side group is on carbon number 2. So this is 2-methyl butanal. Drawing aldehydes. Identify the root, identify the longest carbon chain, draw out your carbons, add the bonds, but add the formal group on your end carbon, and then number from that position for your side groups. So let's say you've got ethanol. Then you've got, your root is ethan, so you've got 2 carbons. There's no side group, so you just put on your hydrogens along with your functional group C double bond OH. So this is ethanol. You could show the bond between the carbon and the hydrogen. I just chose not to. Methylpropanol. So the root here is propan. So 3 carbons contain our formal or our C double bond OH group, so our formal group. Then we've got a methyl. The only place a methyl group can go is on this middle carbon. So this is methylpropanol. Now, why can it only go on the middle carbon? If you put your methyl group on the 3rd carbon, your longest continuous carbon chain is no longer 3 but 4. You will never have a methyl group on an end carbon. So technically this name should be 2-methylpropanol. So you know that that methyl group goes on the 2nd carbon, but because there's only one place for it to go, sometimes we drop the number, the 2. So make sure you always double check your longest continuous carbon chain. Physical properties of aldehydes. The carbonyl group is polar and can accept hydrogen bonds from water, so they're somewhat soluble, but it cannot make hydrogen bonds with water because it does not contain an OH bond. They're pungent, and when they have a small carbon chain, but as they get longer, they smell more pleasant. The boiling point is higher than alkanes, but lower than alcohols, and that's because there's no hydrogen bonding present. But it does have London dispersion and dipole-dipole, so it's a polar molecule. Only methanol is a gas at room temperature, which tells you that the intermolecular forces are pretty strong. So ketones, the carbon for the carbonyl group has to be between at least two other carbons. So it's never on an end carbon. So here, the two different carbon chains are represented by R's. So we've got an R and an R prime. The R prime just indicates that it could be a different length chain from the R. Could be the same, but they could be different. So you'll always have your ketone minimum carbon number 2. The smallest two ketones don't require numbers in the name because there's only one place for the carbonyl group to go. Now, because that carbonyl group is between two carbons, the smallest ketone has to be 3 carbons in length. So here's propanone. Propanone. It doesn't need a number because if that carbonyl group was on an end carbon, it would be a completely different substance. It would be an aldehyde. So we've got propanone and we've got butanone. Now, counting from this end, this would be carbon number 2. Counting from the opposite end, it would be carbon number 3. So we would always go with the lowest number. So that would be 2, butanone. Now, if we draw the double bond on the other end, you can see that this would also be 2 butanone. So these are not isomers of each other. I can just completely flip this second structure this direction, pivot point, and it's the same structure. So these are not isomers. So this structure would just be known as butanone because there's only one spot where the double bonded O can go, and that's on the second carbon. Where we start seeing where we have to place a number is when we're larger than that. If we have pent 5 carbons in a row, it could go on the second carbon, or it could go on the third carbon. So we would have to name these accordingly with numbers. I've shown the bonds where their hydrogens would be. I just haven't put them in so it's less cluttered. So the structure on the left has the carbonyl group on the second carbon. So that's pentan for 5 carbons, 2-one. So pentan 2-one. In the second structure here, the carbonyl group is on the third carbon. So this is pentan 3-one. Or you could say 2-pentanone, 3-pentanone. Why is there not a pentan 4-one or a 4-pentanone? Because that would just be this structure counting from the other end. So because you didn't change where the bonds are, you go with the lowest counting possibility, so it's 2. 2-pentanone and 3-pentanone. Okay, naming. So first thing you do, just like we've been doing, you identify the parent alkane as the longest carbon chain that contains the carbonyl group. Drop the E and add the number and the -one ending for the position of the carbonyl group. And if there's any other side groups, then you put them in as prefixes. So if we look at the structure, here's our carbonyl group. So we are going to count from this end. So the longest continuous carbon chain, no matter if I go left to right or left then down, is 5 carbons. So my root is pent, and the carbonyl group is on carbon number 2. Okay, so that means this is pent and 2-one. Now the side group is on carbon number 4, and it's a methyl group. So this is 4-methyl pentan 2-one. So 4-methyl pentan 2-one or 4-methyl 2-pentanone. Okay, so here we have another compound, and we're going to look for the longest carbon chain. So 3, 4, 5. Now, you might want to stop here, but don't. If there's a kink in the chain, keep going. As long as you don't lift your finger or your highlighter, that is part of your longest carbon chain. If you thought it was a methyl group, you would have possibly 1-methyl pentanone or 5-methyl pentanone, and you will never have a methyl on an end carbon. So the longest continuous carbon chain here is 6. So this is hexanone, and the carbonyl group, you start counting from whichever end gives you the lowest number. So this way would give you 4, this way gives you 3. So this is hexan 3-one. Hexan 3-one or 3-hexanone. Okay, I've done another example for you. The one on the left is a line structure, and the one on the right is almost a structural formula. It's missing all the hydrogens. For clutter's sake, I only put in the bonds. So, naming this structure. The longest continuous carbon chain would be 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, 4, 5, 6, 7, 8. So it is 8 containing the carbonyl group. But one of these gives you a linear side group. That would be an ethyl. There's 2 carbons there. This one gives you not a straight carbon chain as a side group, right? There's 3 carbons there, but it's not 3 carbons in a straight chain. It's like a 2 and 1 on the side. So that's like an isopropyl group. I strongly suggest you stick with whichever one gives you the straight chain. So we're going to go with left to right, the one that gives us the straight chain. So we're going to do the green one, or the one on this structure. So our longest continuous carbon chain is 8. So that's octane. So octane, and the carbonyl group is on carbon number 3. So this is octane 3-one. So that leaves us with our side groups. So we have an ethyl group, 2 carbons, and we have a methyl group. So you can see that on both structures. Ethyl comes before methyl in the dictionary. So you're going to put that first, and then you're going to put in the numbers of the carbons that they're attached to. We have to continue the numbering that we already started for the position of our functional group. So we have a 6 and a 7. So it is 6-ethyl, 7-methyl, octan 3 one. Looks like I forgot my E. There you go. So the structure is 6-ethyl 7-methyl octan 3 one. So when you're drawing a ketone, identify the root, the longest continuous carbon chain containing the carbonyl group. Draw your carbons, add in the bonds, put the carbonyl group on the carbon identified from the suffix, and add any other side groups from the prefix. So maybe we've got pentan 2 one. So we know that we've got 5 carbons, and the second carbon in contains our carbonyl group. So now put in all your other bonds and atoms. So there you go, pentan 2 one. So 2-methyl hexane 3 one. So we know that the longest continuous carbon chain containing our carbonyl group is 6 hex, and our double bonded O is on carbon number 3. So place your longest carbon chain, 6, add in your carbonyl group on carbon number 3, add in all your other bonds, and then place your prefix. So it's a 2-methyl, so carbon number 2 contains the methyl group, and the rest are hydrogens. So there we have 2-methyl hexane 3 one. Physical properties. The boiling point is higher than the same length corresponding alkane, but lower than alcohols. We've got London dispersion forces and dipole-dipole because of the C double bond O being polar. All ketones are liquids or waxy solids at room temperature because they have stronger intermolecular forces than their alkanes. So we have dipole-dipole, which means it's a polar substance. Propanone is highly soluble in water, but the solubility will decrease as the number of carbons increases.